Is that the plan?
Exactly.
Okay,
And then
got it.
we should be live any second. Good morning, good afternoon, good evening, depending on where you're calling from. In Matt's case, very, very early morning. My name is Charles Sterling, and this is with Matt. And today we're actually going to take a look at some vertical industry slices for Power BI. We're going to be taking a look at retail and wholesale industries, and specifically the time and intelligence functionality in Power BI. Is that right, Matt?
Yeah, time intelligence, absolutely.
Time and intelligence. Okay. So before I let Matt introduce himself, what I'm going to ask him to do is go ahead and turn off his camera, because as much as we like to look at Matt, we want to look at his desktop, because that's where all of his sex and his glamour really comes from, is his desktop. And it looks great. We're actually seeing PowerPoint in slide view. I don't know if you wanted to bring it up in presenter view. Perfect. And now the question I always get asked, I'm going to ask you this before we even get started, Matt. Where can they get the samples and more information about your presentation? And I want you to introduce yourself, and I'm going to put myself on mute.
Okay, thanks very much, Chuck. Yeah, so welcome everyone, whether you're watching this live or watching it in delay. So let me start off by introducing myself, then I'll answer that question, Chuck. So for those of you that don't know me, my name is Matt Allington. My background, I literally spent half of my life working at Coca-Cola, and it was a great career I had. I started in sales, and I did a gig in IT for about 10 years. And I just learned a lot about customer service and business through that time. And that's really what's influenced the presentation I'm going to be talking about today, because this is what's influenced my spin on time intelligence. About 4 years ago, I left Coke and I have my own business, and I do a lot of consulting, online training, live training. In fact, I'm halfway through a live training course. I'm here in Melbourne today. I've got a day 2 of my course today. I do a lot of blogging, so there's the link to my blog. And to answer your question, Chuck, any follow-up material regarding this session is going to be available on my blog. Now, I'm not going to necessarily be able to answer all questions today, although I do want to put time aside for questions. But any questions that come through to sorry, Chuck, any questions that come through to Chuck that I can't get that are on topic, I will answer on my blog. And so if you want these slides or to see the video again or to have a look at any follow-up questions, then that's the place to get that. I have a couple of books. In fact, I've got 3 books, although they're essentially the same book. I originally wrote Learn to Write DAX, and I've just recently updated that book so that it is relevant for, or more relevant for, Power BI and for Excel. And in fact, if you buy one of these 2 books, the new ones from my website, the electronic copy of the book, I actually give you both books for the one purchase price, because they are essentially the same book. Okay, so let me get into it. So here's the high-level agenda. Now, we've got about an hour, or just under an hour. My plan is to try and talk for less than 3/4 of that and leave enough time for questions, but I'm not really sure how that will go. So let's just see how time progresses. That's a pun. Okay, so we're going to start off with auto time intelligence. I'm going to cover inbuilt time intelligence and custom time intelligence, because there's actually 3 different ways you can do this. And you know, I can't go super deep, but hopefully enough to give you an understanding. And then we'll have the questions towards the end. So Chuck, if you do get any questions, if anyone sort of is asking about something that I'm talking about, feel free to interject. If there's something sort of about alternative patterns, maybe we can leave it towards the end.
Done deal.
Okay, so here is my, there's 3 types of time intelligence. So just let me explain to you what each one of these are, and then I'm going to show you specific examples for each of these. So the first one is called auto time intelligence. Now, this is Microsoft's way of letting anyone get started with Power BI and to bring a date field into a report and then be able to do things like get calculations by year and quarter and month and those sorts of things. So you don't have to know very much about Power BI to be able to use auto time intelligence. A couple of things that you need to know though: every time you have a date column in a data table, auto time intelligence automatically creates a hidden calendar table, and I'm going to show you that as we move on. So this makes it easy to get started, but there are some limitations, and one of them is that there's no way of doing week by week calculations using the auto time intelligence. Because every date field gets its own calendar table, this can make your files very big. And in fact, I've seen an example of an Excel workbook that was 10 meg. Once it moved into Power BI Desktop, it went up to 100 meg, and that was because the enormous number of date fields. So just be aware of that, but I'm going to show you some tricks and tips to keep on top of that as in this session. And also time intelligence, if you're using this auto time intelligence, there's no easy way to have many data tables. So you might have a sales table, a budget table, a forecast table, something like that, and you want to join them to a common calendar table. There's no real easy way of doing that with the auto time intelligence, although with the new Slicer sync that was released last month, there is one way of possibly doing that, but it's not necessarily the best way, and generally speaking, I don't use this approach. So the second level is inbuilt time intelligence, and this is a set of standard functions that can be used by anyone. They're very easy to write, and as long as you're following the rules, and by the rules I mean following the rules that are set in order to use the standard time intelligence, then it's fine, but the rules don't apply for everyone. So you have to have a calendar table, and this calendar table must be a standard calendar. So, you know, your month of January must start on the 1st and end on the 31st. You can't have 445 calendars or ISO calendars, which are very common in retail wholesale. Also, inbuilt time intelligence is not great if your data is loaded at a week level or a month level, although it is possible to do a hack. So if you're loading data at a week level, you would have to load it on the first day of the week or the last day of the week or something like that. And yeah, so there is a suite of standard functions, and I've actually got a list of those. I'll show you that shortly. The third option is custom time intelligence, and it's also recommended that you use a calendar table here, although technically I think you could just use a date column in a data table. I personally would never do that. One of the advantages of custom time intelligence is you can have any granularity you need. I saw an article by Rob Colley where he had a calendar table that was in the milliseconds, and you could go up to any span you like. So I've certainly done lots of work with clients where they have weekly level granularity, and so we load a week level calendar table, and then we load the data in weekly buckets. And that's also good if you want to limit the amount of space, if you're not interested in day-on-day calculations. Custom time intelligence is the most flexible you can get, but it's also the hardest to learn. So you need to be clear about calculate, you need to be clear about filter, the filter function, potentially values, and you need to be clear about filter context. So this is definitely more advanced, which is why these other two options exist. But I'm going to show you the custom time intelligence pattern as we proceed. Okay, so just let me get my notes up here, and I'll jump into Power BI Desktop. And I'm going to start off by showing you the auto time intelligence because that's the default. And so here's my workbook. Let me show you my data model. I'm using AdventureWorks as I normally do for consistency's sake. And here's my data model. I have a sales table. So every row in the sales table is one scanning transaction that occurred in AdventureWorks. But there's no information in this table that tells me the detail about product, customer, and sales territory. All those details are stored in these lookup tables or dimension tables. Notice that I don't have a calendar table here on the screen. So I'm going to use the auto time intelligence that comes onto this order date column. All right, so let's come back over here and let me show you my measure here. Here's my total sales measure. And if I come down to my total sales measure, it's simply sum of sales extended amount. So the extended amount is the total value of that individual line in that table. So when we add up those numbers, we get 29.3 million, which is the total sales for everything in this database. All right, so what I'm going to do now is, this is a matrix. You know, click here, there's a matrix in a table. This one's a matrix. I'm going to go to my sales table, grab my order date, and drag it onto the rows in my matrix. And when I do that, I get this behavior that you can see here. So even though I dragged a date field, I'm getting to see years here, and the drill down buttons appear. Notice on the right-hand side that you actually get a hierarchy here, year, quarter, month, and day. And this hierarchy is evidence that the auto time intelligence is kicking in. And in fact, if you want the exact date, you can click here and switch to the order date, and now you've got a regular date field. And if you want to switch back to the date hierarchy, you can do that. Now, as I said, there's a few limitations. One of the limitations is there's no week, and that's because weeks are handled differently by different companies. But you also don't have to take everything in this hierarchy. So if I don't want quarter and day, I can just remove those, leaving me year and month. And so now I'm going to do a drill down, making sure that I click on this drill down on the right, the one with the horizontal bar. If I do this one, it abandons the year and just drills down to the next level. And now I've got sales for January over 4 different years. So that's not much use. So I'm going to click on this one. That keeps the year at the top of the hierarchy, and it breaks it down by month underneath. Now, the way this is done, as I mentioned, is with a hidden calendar table. And just to demonstrate what I'm talking about, I'm going over here. This is, I call this my local host workbook. There's a link here, and I'll also put a link up on my in the slides on my website, as I mentioned, so you can download this workbook if you like. But literally what it does is it's an Excel template. You open it up, you click on the refresh button, and it finds a running instance of Power BI Desktop on your computer. It connects to that instance and builds a pivot table, and among other things, it shows you what columns and what data is taking up space. And notice all these tables called local date tables. So I've actually got 6 of these local date tables, and these are all the inbuilt auto time intelligence calendars. And so if I go back now and I'm going to go ahead and write a function, and so I'm going to use the quick measures. This quick measures feature has really developed over the last year particularly, and I actually quite like it now, particularly good if you're learning. So the first measure I'm going to do is total sales year to date. So rather than writing that by hand, I'm going to create a new quick measure, and you'll see in here that there's a stack of inbuilt time intelligence. It's not a complete list, but it's not bad. So I'm going to do a year to date total, and you just have to supply the fields that it's asking for. So the date field is the order date, and the base value, I'm going to use total sales, although I could equally just use the extended amount column if I wanted to. Oops, got that wrong. Okay, so that's all I have to do to write this inbuilt time intelligence, auto time intelligence, sorry. So here it is. Let me add that over here, and let me show you the formula that was created. All of this is just tips and tricks for new users, but this is the actual crux of the formula. And this is actually an inbuilt time intelligence function, but it's using the auto time intelligence, and the way you can tell is this dot date. Anytime you see this dot date, it means that the auto time intelligence hierarchy is being used. And when we put that into the matrix, as you can see, we get a number that increments. Now, I always tell people, if you want to check, if you're going to write time intelligence functions, it's absolutely imperative that you set up a matrix like the one I have on the screen, where you can see the progression of time. And so you can see by month going through different years, you can see time passing by. Here are the sales for each of those months. And when I have this matrix set up, when I write this time intelligence function, I can see that this number is increasing every month. And in fact, I can come in here and apply some conditional formatting, which I also advise. And that just makes it easier to see. And so you can just intuitively tell that this measure is probably correct. It's also your responsibility to make sure that it is correct. So you need to take that into account. Notice that the year-ending date for this is the end of December, which is great for the US folk. But if you're in some of the other countries in the world, you might have a different year-ending date, and that is something that you can change, which I'll show you shortly. Okay, so I'm going to park the auto time intelligence there, and let me come back to my slides. And so there's the link to my local host workbook. It's most of my short codes use this xbi.com.au, and this one is just /localhost. Okay, so let me move on to the inbuilt time intelligence functions. This is the next layer up of capability, quite powerful. Now, I did mention that if you're going to use the inbuilt time intelligence, you must follow the rules, and the rules were set by the developers so that they can accurately take your intentions and turn it into accurate time intelligence results. And so here are the rules. Now, it's important to note that these rules only apply if you're going to use the inbuilt time intelligence functions, the ones that I'm about to show you. If you're doing custom time intelligence, then some of these things are still good practice, but you don't have to follow the rules. So the first rule is you must have a calendar table, but although these will also work with the auto time intelligence, as you've just seen, there must be a contiguous date range, and it must be at the day level of granularity. So it can't be minutes or hours or weeks, it must be days, and you're not allowed to skip any days because the time intelligence uses the progression of daily time in order to be able to do the calculations. Now, one of the official rules is that you should continue your calendar right through to the end of the current year. So even though we're in May 2018 at the time of this recording, the calendar table should progress through to either the end of the 30th of June if you have a financial year, or the end of December if you have a calendar year. I rarely do this because it creates different problems, which I prefer to avoid, and I rarely come across problems, but technically speaking, that's one of the rules. Now, a good date table will have a number of additional columns here. You certainly want one column for every time slice that you want. So if you want to analyze in weeks, then you should have a week column. And also, you should have a numeric sort column for every text column that you have. So by default, Power BI automatically sorts all columns alphanumeric. And that means that a month name column is going to sort with all of the A's first. August and April are going to come at the top of the list. So you need an override column, and I'll show you that in a moment. And also, as I mentioned earlier, it's no 445 calendars, but you can have a financial year or a fiscal year if that's the case.
Hey, Matt, there's a couple of questions. Phil has actually answered it in the chat window, but I want to make sure it's on the video as well. So Thomas is going on and say, what's with the dot date format, the syntax you're using? What's that? What is that all about? Can you talk to that?
Yeah, okay. So thank you for asking that now. So it's confusing, and it's the auto time intelligence. So it's this invisible calendar table that you can't see. So if I jump back here, here is the invisible calendar table, and it's got a number of columns in it. And that syntax is the developer's way of accessing this calendar table for the calculations. And so if I come back here, I don't really want to hack this too much, but if I come back here and go order date and go close bracket, notice now that the IntelliSense kicks in and it gives me access to each of those additional columns. And so dot date is the way of referencing the date column within the hierarchy or within that hidden calendar table, but you can also access these other columns within that hidden calendar table. I understand confusion. I think it's definitely confusing, although I guess once you understand it's there and what it does, then it's perhaps not so bad. Incidentally, I've never turned this on, but I believe in the recent release of Power BI Desktop, there is a way of making this calendar hierarchy visible. It's a preview feature, and here it is here, show dates as a hierarchy in the fields list. And so I believe if you turn this on, you'll be able to see these additional columns in the fields list. I don't know what it does to that syntax. As I said, I've never tried it, and I don't want to turn it on because I'll have to restart Power BI Desktop.
And so, while you're there, I think you're going to probably cover this. You talked about having this amazing bloat, and I've seen that many times. Are you going to cover off how to turn that auto-generated table off?
Yes, I'm going to do that shortly.
Perfect. Okay. I don't want to take that away from you. Go continue on.
Now, when I say, you said amazing bloat, it can be. It depends on how big your tables are and how many date columns. But yes, I'm going to turn them off.
Okay, good.
All right. So I'm talking about how do you create a calendar table, because if you're going to use inbuilt time intelligence, you need a calendar table. So the question is how. So probably the easiest way for the budding Excel user is just create an Excel table. And it can be very flexible. You can just build these manually, or you can write formulas. And so that's probably the easiest way. Marco Russo recently released a DAX calendar table. This is a very advanced piece of DAX programming. Never seen anything quite like it, frankly, but not surprising coming from Marco. So if you want to use that, you can investigate it. There's the link. My personal preference is to use Power Query. I've written a number of blog articles, some of them at Power Pivot Pro. I recently updated this one, and I teach you how to use Power Query, starting from a blank scratch query and building a calendar table that covers all of your needs. Now, just one comment about that is that it can be quite difficult if you've got a really obtuse 445 calendar where you've got different starting dates and ending dates for the year and short weeks at the start of the year. So in that case, I would probably personally default to an Excel table where I can control at the lowest level of granularity what's going on. But for everything else, I would just use this there, and you can read my article. Okay, so let's jump over to the inbuilt time intelligence, and this is where I'm going to do the switch. So here is my inbuilt time intelligence. Currently, I do have a calendar table actually, but I hid it from view. So let me come over here. Here is my calendar table that I've loaded, and it's currently hidden. Incidentally, it's very easy to hide a table. You just right-click and hide, and you can do the same for any individual column if you like, which can make it easier for your end users. So let me unhide the table, and I'm going to join my order date. Actually, just before I do that, to Chuck's point, so here is my calendar table. So notice I've got a date table here. I've got 1, 2, 3, 4, 5, 6 different calendar tables. So as soon as I create this relationship here, because I'm using the order date column, if I come back here and I'll refresh, so reconnect, you'll see that one of those local date tables disappeared. The one called date table template is still there, but one of these disappeared, and that was the hidden calendar table for the order date field. Whereas this one is actually the auto time intelligence. Okay, so if I jump back to my report view now, I've got my relationship. If I come over here, you'll see that this function, this no longer works because of that change that I've made. And so I would preferably turn off time intelligence. And so now, according to the documentation, and let me show you this, if I jump over here to the calendar table, I'm going to go to the modeling tab. This is a relatively new button, markers date table. Incidentally, this markers date table has been in Excel Power Pivot for years, but it's only in the last couple of months made it into Power BI Desktop. So I'm selecting my calendar table. I go markers date table. It says, where is your date column? And note this message. It says, when you markers date table, the built-in date tables in Power BI are removed, and this may break your function. So click OK. But what I noticed in preparing for this call, if I come back here, I've got 5. If I refresh, notice that one of them's removed, but I've still got 1, 2, 3, 4 hidden date tables in this workbook. So that to me didn't seem to do what it promised. And so the way to turn it off completely is to come to File, Options and Settings, Options. And if I come into Data Load, here is the Auto Time Intelligence setting. It's on by default, and you can't turn it off globally. You can only turn it off workbook by workbook. And so I normally turn it off if I have a problem, or I turn it off if that .date syntax keeps kicking in every time I try and write a formula and it starts to annoy me, then I come and turn that off. So once I turn that off and I come back to my localhost workbook, and now if we refresh again, you'll see that all of those hidden tables are gone. So it seems to me that markers date table is not quite doing what it says it would do. Okay, so the year-to-date has stopped working. If I come back here, now also just as I was preparing for this call, I need to remove my order date and put my calendar date in here first, so I've done that. But this is still not working, and if I come in, I could probably hack this. In fact, I don't want to use the sales order date anymore. I want to use the calendar date as my date column, and this is filtered. If I change this, it should also be the calendar date. Now, when I was doing prep for this, this still didn't work, and I'm actually quite surprised because from my perspective, this is a valid function. But if I was to delete all this other stuff, I was able to get it to work when I was doing my run through. So I think there's some little quirky overhead there coming from the quick measure that I'm not really sure about. I'll have to ask Will Thompson about that. All right, so just let me check my notes. So you can hack those measures, and I really encourage you, when you're using quick measures, to look under the hood and see what's going on, because this is how you learn to be more powerful in the DAX language, is looking at what the automated tools do and then doing a little bit of hacking from there. So now it is possible, if you've got a fiscal year or a financial year to date, you can come in here and all you have to do is add another parameter. Just hit a comma. Notice it says there's two optional parameters, filter and year-end date. This syntax is a little bit inconsistent with Excel. You can just completely ignore the first one and specify a year-end date. So I'm in Australia, so 30th of the 6th is the end of, so for the US folk, that's 30th of June. I guess you work that out. In actual fact, it works if I do it this way as well. It's supposed to follow your language settings. But just specify any end of financial year date that you have, and the time intelligence function will just work. I'm going to rebuild my calendar table here. Notice when I bring the month, well, I did that wrong, sorry. Notice when I bring the months in, that the months don't sort correctly. So this is that issue that I mentioned, that months automatically sort by alphanumeric, and it's a very easy fix. All I have to do is click on the month name, come up to sort by column. The default sorting is by the month name, and instead I'm going to sort by the month number of year. And this is why it's important to have that column in your calendar table if you want it to sort. And you can see my financial year to date increases through to June and then resets in July. Once again, notice how much easier it is to do a bit of testing if you've got your conditional formatting. I'm going to return this just to the calendar year, just so that I can, because my month sort order and my years here are in calendar year order. All right, let's write another inbuilt time intelligence. I'm going to, I'll leave year to date in there. I'm going to do year over year. So, so what's the growth this year versus last year? I will actually remove this year to date just to remove the confusion. So I'm going to do a new quick measure. As I said, these are really growing on me. So I'm coming down to the year over year change. Similar layout as before, but this time I'm using a calendar table. Notice that my date column's got this special icon here saying that it's been identified as the official date column for time intelligence calculations. So that one needs to go in here. And my base value, once again, I could use extended amount, but I prefer to reuse my measures. How many periods, or because this is year over year change, it's how many years. So that's all I need to do. This quick measure actually does the formatting for you as well, which is quite nice. Let's first of all check that it seems to be working. So it seems to be okay. Nothing happens until July when we've got a number for the previous year. I can't actually see what the previous year number is here. And in fact, there was no quick measure to do that, but I'm going to show you how to hack that in a moment. So this is using the variable syntax. It first of all defines a variable. Not sure why they've got these double underlines, but it defines a variable, which is calculate total sales. And this date add is one of the inbuilt time intelligence functions. This is covered in my quick reference guide. I'll give you a link to that in a moment. And this is just doing a time shift. It's saying go back 1 year and give me the sales for the period 1 year ago. And then it does the division here. But hopefully you can see that this is actually the part of the formula that calculates the sales for the previous year. So this is one of the ways that you can hack these formulas. I'm just going to copy that bit of code, and I'm going to write another measure. This one I'll do manually, total sales prior year. And I'm going to reuse the bit of code that I hacked out of the quick measure. This one's not going to be auto-formatted, so for consistency, and I always recommend as soon as you write a measure, apply the formatting, do it once and you don't have to worry about it again. And now you can see that it's working. So here's July 2002 is 50,000. For the prior year, it was 473,000. And if you're in a business like I was in, you're definitely going to want to know what's the absolute change. So it's one thing to know the percentage change, but it's another thing to know the absolute change. So from there, I'll just write another measure, change versus prior year equals, and it's just a simple subtraction. So we want the total sales minus total sales prior year. And put that into the matrix and immediately apply the formatting. Now, once again,
actually, before you move on, I think Nick Brady has a question exactly on that you may have just covered. I just want to make sure that you've covered it. It says, Nick goes out and says, the question is probably best kept to the end, but for 454 calendar, when comparing the sales from one year to another, specifically a retailer has 53rd week, and they want to go out and compare the 53rd week against the 52nd week. Would you use that technique that you just used, or would you use a different technique?
So I understand the 445 calendar stuff, and I will probably defer a better answer to my blog article, because 445 calendars are so complex and everyone's different. And so in this example, we're talking about a 53 week. So there's a few different patterns that you can use. One of the patterns is to create a column of comparison values, so that in a second column, you say that for this year, I want to compare it against a column for a previous year. There's many different ways of answering, and I'd like to defer it, Chuck. But what I would ask the person that asked that question is, if you could share with me a copy of your 445 calendar, then it makes it easier for me to answer the question, because it really depends if your week numbers map to the same. I mean, week numbers normally map to the same month, to the 445 month. But do the day numbers map to the same week numbers? There's lots of little nuances there that make them extremely complex. But the easiest way to give one definitive answer is to have one accurate 445 calendar or 454 calendar that I can use. And
before, I know I'm taking time away from you, but Ranjit and Thomas both had the same question. Actually, as do I. One of your slides, and I missed a slide, says that Power Query and AM is a better way of actually going out and creating those underlying date tables versus DAX. I always use calendar and begin date, end date. It's easy, it's done. Why is Power?
I didn't say it was better. I said I said it was my preference.
Oh, okay. And why is it your preference?
I just like to do all of my preparation of tables before I get into the DAX language. Now, if I have this power, now with you can cut and paste a calendar table in the DAX language and put it into OneNote and then reuse it later, so that's fine. But I guess it's personal preference. I just like the capabilities of being able to build from the base using Power Query. If I then wanted to do something like load a working days column, so let's say I wanted to extract public holidays from a website and add a column against my calendar table that told me, well, is this a working day or not? I can do that really easy in Power Query, and I can't do that inside a DAX calendar table. I'd have to load a separate table and then maybe use a related table function or something to bring it into the DAX calendar table. So that's one reason that I can think of. But you know what? There's no one right way to do this stuff. And so if you're using the calendar function in DAX and you like it and it's meeting your requirements, then you've got a great solution.
Okay, perfect. Thank you.
All right. Okay, so when I did my change versus prior year, you can see once we have prior year sales, we end up with what looks to be a useful number. But these numbers up here are not really useful because we actually weren't in business prior to July 2001. And just like you would handle this in an Excel spreadsheet, you can do exactly the same here. I can just really say, look, if there's no sales in the prior year, then I don't want to return the result. So I'll just say if total sales prior year doesn't equal 0, then give me the answer. And the benefit of doing that is that it will just get rid of these periods here when there are no sales in the prior year. You may have to do the same thing at the other end. This is what I call calendar overrun. So this problem here doesn't happen as long as you don't load your calendar table into the future. As I mentioned, under the rules of the calendar table, the recommendation is that you do load the calendar table through to the end of the year. And this is one of the reasons I prefer not to do that. And generally speaking, I don't have a problem. Okay, so let's do another formula. I'm just going to remove these just to give me a bit of space here. So I'm going to remove these. I'm going to bring back my total sales year to date. And that's interesting. It kept the conditional formatting, even though I removed it from the matrix. That's interesting. Okay, so what if I want to know total sales year to date this year and total sales year to date last year, and therefore the change versus the same period year to date last year? And so I can go ahead and do that. I'm going to do another quick measure. And what I want to show you is that you can nest your time intelligence functions inside each other. So let's go and do year over year change. I'll bring my calendar in here. And this time, instead of using my total sales as the base measure, I'm going to use my total sales year to date as the base measure. And when I do that, I end up, let me add it, of course. I think it's this one here. You can see that I've got my, now the reason this is such a large number is because it's ramping into its year to date. But you can see that it is possible to nest time intelligence functions inside other time intelligence functions. And so that's not a bad way of doing things either. Okay, so of course you can write these time intelligence functions manually, and the IntelliSense is pretty good. And one of the key things that you need to do is be aware of what the custom time intelligence functions are. And just to assist with that, so you can use the IntelliSense. So as you start to type the functions, the list of functions comes up. But just to make it easier, I give this to my students in my training class, but I've created a quick reference guide. It's a PDF. It's all hyperlinked by function category. So if you click on the time intelligence, it'll take you straight to this section, and it gives you a list of all of the functions, the syntax, and basically what it's used for. So this can be a quick way of finding what you need. As a general rule, the developers that produce this this product, you know, they understand what the business requirements are. So generally speaking, they probably do have a solution to your problem, and you might have to use custom time intelligence in some cases, but certainly go looking for the function if you would like to do that. Okay, let me move on to the last topic, which is custom time intelligence. Just some general additional advice for custom time intelligence. The first piece of advice is I always like to add an integer column that starts at 1 and grows by 1 for every item. And so let's take a month, for example. So you would already have a month column that says month 1 for January, 2 for February, 11 for November, 12 for December. So you need to keep that column, but I also recommend that you do another month column, call it month ID, and instead of resetting after 12 and going back to 1 again, you want it to go 12, 13, 14, 23, 24, 25, 26. So by having an integer column for the month column, you're able to do calculations using integers. So you can say, find out what the month number ID is for this period and go back 11 months and give me a rolling period between the last 12 months. And that's much easier to do if you have an integer column at that level of granularity. I also recommend that you don't embed inbuilt time intelligence functions inside a custom time intelligence function. And I've learned a lot about this over the last week, actually, and there's some under the hood activity in some of these inbuilt functions that is not immediately obvious, and you can get unexpected behavior. Now, I've also observed that if you're using the variable syntax, this generally is not a problem, but if you nest inbuilt time intelligence functions technically inside a filter function with a row context, you can get unexpected behavior. So just be aware of that. And I also now recommend that use the variable syntax where possible. It makes your functions easier to write and also a lot easier to debug. And so, and then when you come back later on and try and understand what you did, you can read what's going on a lot easier as well. Okay, so it's 20 to the top of the hour, so I really don't want to spend more than about 10 minutes on this, but this is the most complex title of all. So one of the most important things that you need to do before you are able to write good quality custom time intelligence patterns is you need to be able to read the filter context, or in other words, you need to be able to read what filters are impacting an individual cell in your pivot table or your matrix. And so in this pivot table, I've got this green highlighted cell, and there are two filters that are impacting that cell. I have a filter on calendar year as 2002, and I have another filter on the month name is June. Now, that's obvious, but what's less obvious is you need to be clear in your mind that what these two things are doing are putting a filter on my calendar table. And what I teach my students to do is almost to the point of close your eyes and imagine what does the calendar table look like at this point after the filter has been applied. And I'll describe it to you. So the calendar table has a filter on calendar years 2002 and calendar month is June. The calendar table in its filtered view therefore has 30 rows in it. The first date you'll find will be the 1st of June 2002. The last date you'll find is the 30th of June 2002. And in fact, the easiest way for you to visualize this, if you're using Excel, is to come into Power Pivot and actually physically apply those filters. And so I've got a calendar table loaded here, and I can physically apply those filters. Let me jump to my calendar year column, and I'll put a filter on calendar year is 2002. Before I do that, notice there's 1280 rows in the table. As soon as I put a filter on 2002, I'm down to 365, not surprising. And now if I go to, well, here's my month name, and I put a filter on, I haven't got my sort order here, put a filter on June, you can see that the calendar table with these filters applied have got 30 rows. The only value in the month name column is the word June. And here is my month ID column that I mentioned, and the month ID for this column is 12. And so I'm able to use custom time intelligence patterns to extract the value of the month ID, even though the month ID is not necessarily in my pivot table or my matrix. And this is the key point. When a filter gets applied to a table, the filter applies to the entire table. If you can mentally understand what filters have been applied, you're able to write formulas to extract any of these values from any column in that table with the filter applied. So I hope I didn't overly complicate that. It's a complicated topic, and you can go back and watch the video again if you want to hear that again, and give me feedback if you think I could explain it better. Okay, so this is the important thing. This cell is being filtered. Here is a year-to-date custom time intelligence pattern, and it's a little bit confusing. You can have a look at it on the screen and come to your own conclusion about what this, how this function works. But I'm going to explain to you each of the pieces of this function. So I'm assuming that you have an understanding. So calculate modifies the filter context. So the initial filter is on calendar years 2002, calendar month name is June. So that filter has already been applied. And therefore, the first thing we need to do when we write our filter function, if I want to go back in time and get sales for January, February, March, April, and May, as well as June, before I do anything else, I have to remove the filter. Otherwise, the filter is already on the calendar table and I can't access the previous month's sales. And that's what the all calendar piece does. The all calendar says, remove all the filters that you find in the current visual, because if I don't do that, I won't be able to go back in time and grab some of the earlier periods of time. So that's why we must have all calendar. So technically, filter is going to work its way through an unfiltered copy of the calendar table. And then these red and green pieces play a different role. So whenever you see a red, I call this a naked column, so there's no aggregation function wrapped around that. It says, go and put a new filter on this column. So this first row here says, go and put a new filter on the calendar date column where, now this is confusing, less than equal max of the calendar date. So let me explain what the max of the calendar date means. Anytime you see an aggregator like max, min, average, sum, values, selected value, anything like that that returns a scalar value, what it's saying is go and have a look at the initial filtering and tell me what the maximum value of the calendar date was with the initial filtered, with the initial filter applied. So if I refreshing you here, the last date would be visible would be June the 30th. And so this row says go and put a new filter where calendar date is less than or equal to the 30th of June 2002. Now, of course, that's going to give me sales all of 2001 all the way up to the end of June 2002. And so we need this double ampersand that says and. Also put another filter on the calendar year column where the calendar year is equal to the max of the calendar year. What is max calendar year? It is, there's only one value in the calendar year column, and that's 2002. And therefore the max of the calendar year is 2002. And therefore it gives me a year to date. And I could equally have changed max. I could have used min. I could have used values. I could have used selected value, all sorts of different functions. In this case, would give me the same result. So once you understand this pattern, you can reuse it for pretty much any type of calculation. You just have to remember to remove the filters and then go back and apply the ones that you want. And the easiest way to get your head around how to do that is to use an Excel table, apply those filters manually, and then once you've done it manually, you'll know what you're trying to do automatically. Now with the variable syntax, it's much easier to understand this pattern. So this formula I have on the screen is exactly the same as the one that I just showed you, but it's a more modern implementation, and I recommend you do it this way. The reason I showed you the other way first is that often if you go out to websites and blogs, you'll find that other older pattern deployed, and it's helpful to understand how that works. And so I'm just breaking down each piece of the puzzle and giving it a good name that clearly describes to the reader exactly what this piece of the puzzle does, and also adding some comments to make it easier to debug and to understand. So first of all, I create an unfiltered copy of the calendar table, which is all calendar, and then I define the last date in the filter and the filtered year, and then I just redeploy that using the reference to the variables rather than the min and max. And I hope you agree that that's a lot easier to understand. I do have a text-based copy of that exact calendar, of that exact function. So this will be on my slides, and you can copy that text if you want to reuse that later on. All right, I do want to do a demo of a rolling 90-day average, and then that pretty much wraps up. So it's 12 minutes to the hour. I'll try and pick up the pace on this to try and fit in some extra questions. But what I did want to do is show you the process that I go through. So this is going to be a rolling 90-day calculation. And I'm going to start off, I'm going to use the variable syntax, but I'm going to start off just calling it work in progress. And the first thing I'm going to do is define a variable. So variable, and my first variable is going to be an unfiltered calendar table. And that's just going to be all calendar. Now, when I write these functions like this, I like to test at every step of the way. So I'm going to return. Now, I can't return the table because that won't work, but I can count how many rows there are in the table. So I'm going to return a count of how many rows in the table. Let me just remove this for clarity. Here's my work in progress measure, and you can see that that part of the formula is working. So this is the way I always write my variable-based functions. Okay, so the next thing I want to do is I want another variable, which is the last date selected in the filter context. And as I just showed you, we can use a max of the calendar date column to return that. And just to test it, I'm going to return the last date selected and my work in progress measure updates, and you can see that this looks correct. I've got the last date is the 30th of June, so that's all working fine. Okay, now because this is going to be a rolling 90-day average, I need to know what's the starting date. So I'm going to write another variable, start date, and hopefully you can see that as you break the puzzle into pieces, to get the start date, I just need the last date, and I've got to subtract 89. So it's not 90 because it's going to be inclusive, so I need to subtract 90 days. And so now I can check whether that's working by returning the start date. And so this is a rolling 90 days. I'm going to change this pivot table in a moment, or this matrix. So even though the last date is June 30th, 2003, the start date goes back to April to give you my 90-day rolling total. All right, so from here I can actually return my, using the pattern, so I can go calculate total sales, and then I'm going to, oh, that's a little, I think that's a little IntelliSense bug personally. We'll go filter, an unfiltered copy of the calendar table, and I want to put a new filter on calendar date is greater than or equal to the start date, and another filter on calendar date is less than or equal to the end date, sorry, the last date selected. I need a couple of closed brackets, and I'm going to actually switch over to this other matrix here. So I've got the day level in here, and I've got my day IDs in here as well, so that you can sort of see what's going on. So here is my my number now. Now this is actually currently giving me a cumulative 90-day total. So after 1 day, it just gives me one number. After 2 days, it adds two together. But once we get up to 90 days, it starts to progress from there, giving me a rolling 90 days. And so if I was just to do this, if I go straight divide by 90 to give me, this is going to be my my rolling 90-day average daily sales, this technically is not going to be correct, because my formula is not returning 90 days worth of sales until we get to the 91st day or the 90th day, and then it starts to be correct. So strictly speaking, I've either got to filter these out or find some other way to deal with it. And the way I prefer to deal with it, I'm going to grab this filter function here, and I'm going to turn it into a variable. This will make sense in a moment. So I'm going to Control X, create a new variable. This is my filtered table. No spaces. So there's my variable filter table, and I'm going to just comment this out for a moment. And I'm going to, I can't return a filtered table, so I'm going to do another variable which tells me how many rows, count of days, is a count rows of my filtered table. So this, and then I can return the count of days. And if I check that, you'll see that this count of days snippet correctly increases in number all the way to the 90th day, and then it sticks at 90. And so instead of dividing by my 90, I'm going to return, get rid of this, I'm going to return calculate total sales. I'm going to pass the filtered table to that and divide it by the count of days. And then that's going to be self-healing. You could argue that it's not technically a rolling 90 days, because in the first 90 days, there's not 90 days worth of sales, but I think you'll agree that's close enough for the exercise. All right, so I want to pause there at 6 minutes to, and we've got a hard stop in about 6 minutes. So I'm more than happy to take questions. Also, I just want to point out that I have got some online training courses that I've got the links for here. I'm offering a 20% discount if you use this coupon code for the next few weeks. So if you'd like to attend either my Power Query online training or my DAX training, you can look more about that on my website. So Chuck, questions?
You know, actually, Phil Seamark, Michael Shebner, and Adil, and who else? Actually, one other person is doing an amazing job of answering the questions for you. So
I got helpers. Fantastic.
Yeah. Big shout out to Phil Seamark, because it's kind of early for him, just like you. But it looks like we're actually mostly caught up. A couple questions and actually requests for doing a series on different custom visuals, when to use which, where, and what, because actually the question came out to, and I'll ask the question, what do you usually use to display year-on-year growth? How do you actually do that? And
okay, good question. So so it depends what you mean by year-on-year growth. So this is one of my pet passions, actually, and I haven't sort of really thought this through, but I did mention, maybe I changed my, let me find a suitable thing here. So I'm going to bring year on year. I'm not sure, is that the year-to-date one? So that's the percentage growth year on year. And then I also did a change versus prior year. And so particularly when you get, actually, I'm really thinking about the year-to-date. So I hate doing year-to-date bar charts because the numbers just continuously get bigger. So they start low in the bottom left-hand corner and they grow forever until the top right-hand corner. And so even if I did, let me show this. If I put year-to-date and then I put year-to-date prior year, which I think I did. Did I do a year-to-date? I didn't do a year-to-date prior year, so I'm going to quickly do that same hack. Copy that. New column. Total sales. I won't worry about the typo. Prior year. And I won't worry about the formatting, just to say, oh, did I do a column then? Oh, that's bad mistake. I hate columns.
Yep.
Total sales, year-to-date, prior year, measure. I won't bother about deleting that column. Never do calculated columns. All right, so if I put that in here and turn it into a column chart, I want to demonstrate the point. See how these charts, let me put a filter on one of the years that's a little bit more useful. So I'll go, let me give, don't like that either. Hate it when I'm trying to be fast. All right, so here's a good example. I hate this visual. This is the worst way to visualize what's happening year on year, this year versus last year, year to date, because the only thing I care about is the gap between the bars. And so if I care about the gap between the bars, then show me the gap, don't show me the bars, if that makes sense.
Yes, it does.
And so I would definitely write a new measure here that says change year to date versus prior year is equal to total sales year to date, subtract total sales, wrong one, year to date, prior year measure. I'm going to stick that one into my matrix. I'm going to remove the year to date. Now, even here, you can see how much better it is. But I would argue you don't need to see the year to date numbers in a bar chart. If you want to see the year to date number, then come up here and drop it on as a, I'm going to have to change the size here, drop it on as a card or something like that, so that you can see the actual number, and then you can put another card and so on. So if you want to see the total number year to date, there it is. If you want to see what's happening, this is what's happening. We're trending down until the first half of the year, and then we had a pickup. That's the valuable information. Now, also, I just do a plug for Marco and Alberto. They have a great little download, which once again I give all of my my students, if I can find this under pressure.
That visual creator or that visual selector PDF.
Yeah. So
yeah,
and that's
I'll put the link in because that is amazing. So we're at the top of the hour. Oh, you've got it. Okay, perfect. I'll put the link in.
This is a great visual. Chuck will post a link, and it gives you advice on how to visualize stuff.
And then based on Michael's request, we actually use, like what Matt was showing, we actually use the Zebra BI visuals inside of Microsoft. And based on a request, I actually created a webinar for next week. We're going to have that at Tuesday at 10 a.m., walking you through how we actually do those year-to-date growths on a monthly basis, so you can actually see those deltas. So thank you very much, Matt. I really do appreciate it. And thank you, Philip, Michael, Ranjit, Alexander, who was chatting with me in Russian. You guys have a great day, and I'll see you next week.
Thank you. Bye all.